Yeah, this is another simulation exercise. We are going to do some sorting here. Item sorting. Item that are entering a transport, and we have to kind of eject them or sort them onto two other transport. So you're going to program this, and in this compendium that we have, there is an example, a programming example that we can have a little look at here too, in here. So it's basically this model that we have: two detectors, two ejectors, cylinders, or whatnot. These times they should probably be different. And there are motors, two motors to control this transport, two, and a main motor here controlling this transport. And down here too is some description and maybe an interface, a suggested interface, how to connect it, using an external function that you can embed into this one. Maybe you should do that. Find a state machine, suggesting some pseudocode for this state machine. And this has to be a finite state machine. So if we look at the exercise itself, so this is down in exercise, I think it's the last page. Yes, here is the model, what we actually have. And here is the function that's doing a continuous feed. So here are some errors and things like that you can have output. It's just an interface of my solution. But here is the model itself. We have two detectors, three motors. Here's some cylinders you can eject, and here's some legend too for the model. We can maybe, so what they do, for instance, this is that the actuator's being controlled back in or back out, and so on. The motor is being controlled, and you can fault the motors just to test how your program is reacting, and so on. So this is what we are going to look at. Now, if we go back to the top here of the exercise, this is the exercise. Here's the emulator, and this is what we want to make. There's a sort of zero in here, which is basically the interface. We know nothing in it, but you are going to program this 1 and 2. And then there are instances for this, and then also there is in the solution where we use inheritance, because when we make this program, just as one program, we are going to get repeating functionality here, and then it should say a little ding dong and say, okay, maybe we should make a function block. We need a function block for each sorter, something like each cylinder or ejector, or whatever you have, and inherit that twice. So use that twice. So the assignment is, and here is what the purpose of it. So it's write an advanced finite state machine function block. And this is a finite state machine which should execution. We're going to make two programs. The first one is going to sort individual items, so eject individual items, and the next is going to be a stream of items. So you have to remember that they have been detected and kind of keep track of those in the transport and get them all out in the right place. Yeah, and what you need again is your PC, preferably two screens, doing some program on a 10-inch screen on a laptop or 15-inch. That's not something we do. That's an exercise that we don't do. So you have to make this order 1. So here's what it should do and should be called. And here is what it is called in program 1, and this instance data block, and here's the interface for it. That interface is in this document too, and can be copied to a source file and imported into a portal, so you don't have to write these inputs and outputs. And here is how to call it. So here's ... So there's more to it, but there's two forced one, and then output, and how to call this function. And here's how to program start the motors. If there's fault on the motors, maybe you should indicate that by a fault output, and detect a blue one. That is this BH1 from the simulator, but it is in the tag table. It's called BH1 because it's related to the model, internal model. Your program will call this XGC1 or something like that, detect of cylinder 1. But whatever, wait some time and eject. So the blue one to conveyor 1, it could be green, and then there's green one, there's another detector, wait another time too, so it should probably be a parameter, and eject it there, and download and test this. use feed single item, which is a command on this emulator. Function interface is suggested. Variables are suggested with constants too. There's quite a lot of constants here. We need a couple of, if we are writing just one program, we need maybe a state machine for the motors, and state machine for cylinder 1, and a state machine for cylinder 2, and cylinder 1 state machine, and cylinder 2 state machine, injector 1, 2. They are identical, so maybe we should make a function block and inherit that too. And also maybe we should make a function block for each of our actuator, that's checking the feedback. Is the motor starting and giving us an error? If it doesn't, if it's you stop it, is it stopping? If it doesn't, it's an error. And if the cylinder doesn't eject or retract or something, extend or retract, that's an error, and so on. And then you need a fault reaction. What should be the fault reaction in a system like this? Maybe you should just stop the system and wait until the error is corrected with a fault. I don't know. It's a little up to you. So here is this I/O in the interface, the two detectors and inputs and outputs here too. So the inputs here, they are outputs from the model and inputs to your program, and the outputs here is input. They are inputs to the model and outputs from your program, as indicated in the figure above. And here's the documentation, program listing, and so on. And of course you should do testing and see if it works, but we are not asking for the test results and something to document it. That's a little difficult. But if you want to, you could document maybe by making a video and say, okay, here it's sorting nice. My program work as demonstrated. Now we have handled single feed of 2 items. Now we are going to change this to handle a continuous flow, and then we need some memory in here. And maybe we should use some constants, because if you have a single FIFO, a FIFO is first in, first out. So we are just mimicking the transport, because the item first entering the transport is going to leave it first. So it sounds like a first in, first out system. We're going to make a FIFO. If you don't know what it is, you can use ChatGPT or AI and find out what it is, or Google search, or whatever you prefer. Okay, this one should probably be in capital letters, so these are going to be constants too. I think too, if we look at the supposed interface here, what we have, we don't have anything for the items in there, do we? Zoom in a little. No, so maybe you should make constant for items too then. So this is just a statement. It's basically this for the assignment 1 and not the 2. Yeah, so that's what you have to extend it. So you need a FIFO of some sort. And the blue items. And then here is the information, what you have. You could copy this to a text file, import it into TI portal and generate this interface, and you see there's no operation here. So the code you have to write yourself, but you wouldn't need to write this too. Between 1 and 2, maybe you need more. You should add something. But enable your transport, so you switch it off, you stop the motors and so on. If you switch it on, enable to start the motors and do the sorting, and maybe an enable would be nice to have. So it's a state machine. Yeah. So here is how to do it. Let's say make a structure of this FIFO, which is an array structure. Maybe you could use a type 2 here. Made sense, because the structure is a special Siemens stuff, embedded structures, embedded types. Maybe you should use a PLC data type. Then again, what's bad with Siemens is that the PLC data types are located somewhere in your projects, way down there. You can't keep your data declaration with the program that you are using. For instance, if you're working codices and something like that, these data types, you can just make a folder and keep the data types next to the function block you are writing. So you can collect the code. It's not possible here, but you should probably use a data type. And here is this handling this FIFO. And if we have a single FIFO, we could use 2 FIFOs if we want to, but here we are mimicking the transport. We have 1 transport, 1 FIFO. and they are blue and green, and we have to identify those, and we use a number just to identify them. And we have the entry time, because that's what we're going to calculate on the FIFO. How long has this item been in the FIFO? You don't have to treat it as a FIFO tool. You can just search and find an empty location and enter it, and just run through the entire array and check how long these items have been here. But if you use a FIFO and roll it down, you are pretty sure that the top location is free, because you have just moved the top location entry down to the next level, next on from the top on. And test an item here in front. This you have to do for the item ID 1 and 2. Similar codes, maybe you should use a function. And here is a little, so the waiting time, and then of course we have to check if this time is within, say this item has a certain width. So don't check for 0, because then in the program as it's cycling, maybe you are going to miss the 0 time that you're calculating. So have a deadband and call it whatever you want. This is a suggestion. This is time it takes for the item to pass the detector. And you could also measure the width of the detector with the speed you have, how long the time it takes for the item to pass the detector. Let's just detect a positive edge and a negative edge and measure the time in between here, if you want to. And when you do that, so if you detect one in sorting slot, there's a sorter extend for C1. And here we use an array for these state stores that we have in just an index. So it's state, and this is cylinder 1, and then it will be for cylinder 2 with constants. Sorry. Ideally here it says a little about what this should be. The transfer model has the following instance data block, where here you could, this is basically handled by this HMI interface that we have, but here you could adjust something. And you could read down here. Let's say if you don't use the interface, you can manipulate directly in the instance data block. But pay attention here to ticks per item. There are quite a bit. There are some things here that you should not change, because they are for the animation, the geometry of this transport and how many items are there and so on. Ticks per items and so on, you shouldn't change that. But this item spacing ticks, you could change that and increase the spacing between these items. A 0, maybe you will probably not detect items, it's just a stream into your system here. But of course you could check out what is your program doing if it can't detect items and so on. You can make a pretty elaborate program here for this with this says what can be. Now we looked at this and started the video. So here's how you operate it, and here it says how to operate on the module. So here's the motor. You can force the motor, a fault on the motor, just force it to stop. See what your program does. And here's for the cylinder, we can simulate 2 high feedbacks. It's both retracted and extended at the same time, which shouldn't be possible. And no feedback, low, and we have no feedback, so it's stuck in somewhere in between this ejector they have. There's something wrong with it. You test that and see what your program does. Be careful for the model. If these are faults on the feedbacks. Maybe you have to extend the cylinder, but then these items, they would just pass under the cylinder here, because the cylinder, we don't know where it is. We just say that's retracted. But if you extend the cylinder, of course, these items wouldn't pass, so they would be stuck here, and they would just kind of stack up on the back here, and it wouldn't work. So you could try this one, the lower one just locks it back so it wouldn't extend, and you can see what's your program doing. It should do something if this ejectors the cylinder doesn't work. So you have to have some half intelligent solution to something not working. And again, the fault retraction here is maybe stop the transfer, stop everything, give a message to an operator or someone, the handyman, go and fix this transport. This cylinder isn't working. So your program should maybe output some faults here. So this is an interface again from the program I made to do the sorting. But of course, you could also make an interface for your program. Then, of course, this is the interface to, so see, it's external writable and things like that. But here you would need, when you import this, you would have to make it available in HMI and so on. This metadata that you set in TI portal. I think that's all there is to this. So this was a new simulation exercise, a not so easy exercise. Has to be programmed as a final state machine. If you try to do this with set, reset, flip-flop for other type of memory elements, binary storing, and so on, you're going to run into problems. And then again, too, finally, maybe you should make a sub-function block that you inherit to an overall function block controlling one actuator, and then maybe you should also make a function block handling one sorter, one ejector. And that function again maybe should call this sub-function that's controlling the motors and the cylinders. So then you got nesting one main function, one that's handling an ejector, and in there again you are handling the, I said, extend, retract routine and write something like that. In what I suggest as a solution, a part of the solution, that's one of the solution where you program that. And you could also but then if you do that, then you're going to inherit also the storage for each of these ejectors, and then you don't have a fee for just mimicking your transport one. But then from a programmer's point of view, we have got repeating functionality, and then we make subclasses, so make new classes, and here with those, here with function blocks, and here with those, and just stimulate the function blocks to do whatever we have to do. Yeah.